Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
So we've been working with time series data in our image collection for both our region of interest and for our 1,000 random point locations within our region of interest. And we're specifically using the TerraClimate data space or data set or data product, depending which one you want to use. It's up to you. Anyway, so the last one we actually worked on a harmonic regression function for our time series, in that we're trying to mimic, or we're trying to model the seasonal patterns of maximum temperatures, or for whatever variable you want to focus on. So that's what we did in our last video. So we've got a couple of videos now that's working on regression, but basically just regressing constant and time against itself. So what we call just a single regression. We haven't looked at including other explanatory variables or independent variables, that may have a relationship with maximum temperatures in our case. So we're just focusing on regressing time and the harmonic, the cos of time and the sin of time and the constant, and then basically, its own past. So that's what we've been working with over the past number of video tutorials. The one that we're looking at to do now is actually including another variable in the regression equation. So we're not just looking at time and in a constant as in the previous, but we're actually interested in adding another variable. So in this case, we're going to have 4 variables, 3 independent variables and 1 dependent variable. Okay, so this is a little of a detour from our previous tutorials, but nonetheless, and again, I've just included another. You can explanatory variable or independent variable. You can include third one, a second one, a third one, a fourth one, a fifth one. That is totally up to you, depending. But remember, you should be always in mind of the normal regression criteria or regression parameters. You shouldn't have too many independent variables, multicollinearity, and all of these things that you should be on the lookout. Okay, so bear all those things in mind. Nonetheless, we're going to do a linear regression, okay? And as I said, we're not just going to look at a constant and time as independent variables. We're also going to include a third independent variable, which is a variable by itself, a standalone unique variable with its own observations, etc., etc. Okay, so that's what we're going to do now. Again, here's our reference tutorial. I will leave a link to this website. It's from the Earth Engine community. It's got linear regression, linear fit, linear regression. We're going to do some of these ones, but for now, we're going to focus on linear regression. Okay, so if we go to the equation itself, they don't have it per se, but you'll see there is the content of that. I have reworked this code a little bit, since I'm not working with this particular data set. So for example, that code you can leave out. I've amended that, etc., etc. So I've manipulated the code a little bit for my specific purpose, etc., etc. Okay, so first thing is, like in the previous video tutorials, we generated time band, okay, our time variable. Okay, it's independent. It's basically from January 1960 to December 2022, and it's a number. And we've been through that in our previous video tutorials. I'm sure go and have a look if you don't understand what I'm talking about. Now, this is something new that we're doing. We're dividing it by 1 and 0. So basically, we're dividing it by 8 zeros, 1 and 8 zeros. What's that? 100 million? What's 8 zeros? Yeah, something to that effect. So we're taking the time variable and we divide it by that. And I'll show you now why we're doing that. Okay, and so this variable, by how much you must divide it, is pretty much dependent on the dates. Okay, so depending on your date. But whether it is 2000s or whether it is in the 60s and 70s, etc. But I'll show you now how to figure out by how many zeros you must divide it. You'll see in the tutorial it talks about 18 zeros. Okay, now I'm not dividing it by 18 zeros, I'm just dividing it by 8 zeros. Okay, so we've got the system. Remember that system, if we can reflect, that system start date looks something like this. Okay, it's a 1,000 number, 21,960, 22,000, etc., etc. Now, remember, we're working in temperatures, which is 20s and 30s. So obviously, we can't work with 20,000s. So we have to make this number, the date number, smaller so that we fit with this. But anyway, I'll show you guys a little bit later what we're talking about and why we're dividing it by that number. Okay, so this is a bit of a, oopsie, I shouldn't do that. That is a bit of a hit and miss number and trial and error number. But yeah, I'll show you now how you determine how many zeros there are. Okay, so that's something that you should play around to see what the numbers look like. Okay, remember the result should make logic, should be logic, it should make sense. Okay, so if you see a number, remember we're working in temperatures of 20 and 30s. So if you get a number of 400 and 500, then you must know somewhere there's one too many zeros. Or if you get a 0 and a 2 and a 3, then you know there's two little zeros. So that's how you play this number game here, is determining the outcome and see whether that outcome makes sense in terms of the variable itself, understanding the variable. Okay. And then obviously we're adding a constant band. Okay, so it's our time band and constant band. So similar to what we've done before, we do our normal TerraClimate, data set of image collection. We scale it by our factor. We have our time identification of time bands from our start to the end, which is basically 1962, 2022. Because that's our filter date, that's our start date. Remember, what happens now, that Earth engine converts this number into an actual value that can be used in our regression equation. Remember, each of these dates have a unique value. Okay, and then we're basically adding our time band and we're adding our constant. So nothing new up to there, still what we've done. Now here's where we come a little bit. Here we add, or we select, what our predictors are and what our responses are. Now first you start with your predictors. Okay, so in this case, I've got 3 predictors. Okay, I've got my constant, I've got my system, and then I'm using maximum temperature as an independent variable. Remember in the previous ones, we have maximum temperatures as my dependent variable. Here, I'm just switching it a little bit around, and I'm saying maximum temperatures is as an independent variable. Okay, and here is my dependent variable, minimum temperatures. Okay, so I'm saying my minimum temperatures is a function of maximum temperatures, time, and the constant. Okay, so it's quite important that you specify it in there. If you have more independent variables, you'll just add it here. Okay, the last one will always be your independent variable. If you have more independent variables, then you'll just specify it, and I'll show you how to do that. Okay, so take note of this specification. It's your predictors. Remember, your predictors is your independent variables, or your explanatory variables. In our case, constant, our time, and maximum temperatures, and there's our response variable, or the dependent variable in our case is minimum temperatures. And remember, this is a band in our data set. Okay, so if I go to this data set, just to refresh, if I go to data set, let's quickly search for it. I go to search, I paste it in, I press enter, and voila, there it sits. And if I go to bands, there we go. There's minimum temperatures, TMM. Okay. Now again, what you can do is you can use any of these other variables as independent variables. So you can have multi-independent variables. Okay. So we can do for wind speed, for example, or participation. We're going to get to some of those things a little bit later as well, some follow-up videos that we're going to work with. Okay, so these two bands come from as the variables included in this data set. Okay, and you can do a third one here, you can do a fourth one, that's totally up to you, how many variables. But as I said, remember what OLS is all about, linear regression, in terms of, the ins and outs of that. Don't violate those those criteria and characteristics. Now here I'm specifying two regression equations. First of all, I'm going to do a simple linear regression, and second of all, I'm going to do a robust linear regression. Okay, and there is a difference in terms of the modeling of it. Robust are normally, linear, but you're robust in terms of the coefficients being independent of in terms of serial correlation and autocorrelation and all these sort of things. So this is, this could be white noise coefficients, or nonsense coefficients, because we don't test for stationarity. But let's not go into that. Okay. So here I'm specifying you see here I'm specifying my linear regression. I've got 3 independent variables. Remember, that's the 3 there, which is constant, system, and max. And then I've got 1 independent variable, which is that one there, which is this. Okay, so this is this equation specification, the regression equation specification, which is basically this. Okay, so if you had num y first and then num x, then this would obviously change around. Okay, so please be very careful how you specify this, in that the x variables in our case is 3 of them. They first specified, and then the y variable is second specified, meaning it's last there. Okay, so please check. If you have 4 independents, then obviously you just make that a 4. Okay, or if you have 2 independent variables, you make that 2. Okay, so that's totally up to you, but you normally have 1 independent variable, and that's again a bit of a deviation from, you'll see here from the tutorial, they've got 2. Okay, you'll see they've got that one as independence, and then 2 dependent variables where they have 2 and 2. I've made it 3 and 2 like a normal multiple regression equation. Okay, now same with our robust equation, robust linear. There's my 3 and my 1. Okay, 3 independent variables, which is x, 1 independent variable, and that's again that specification. So please be very mindful of how you specify it. It's very important. Okay, and then here again, our band names. Are we giving these band names? Constant, stay constant. Again, you can call it whatever you guys mean. That's system start. We give it time, and then my TMX there. So that's my x variables. Okay, or 0 axis. That's my x variables there, and then my independent variable. Okay, so again, specification is very important here in terms of the order or the flow of the variables. Okay, so this is what we call them. And then we generate the coefficients. Okay, we generate the coefficients for each of these 2 equations. Okay, remember there's the robust linear regression. There's the robust, and we generate the coefficients. And there's the linear regression, which is this one here, which is again that equation, and we generate the coefficients. So that's what we're after, so coefficients. And then basically we generate a layer for that. And again, that is important in terms of specifying our equation. Okay, so we've got constant and its relationship with the dependent variable. We've got time and its relationship with the independent variable, and we've got this independent variable and its relation with the dependent variable. Okay, so that's how you specify it. So if this was, let's say, minimum temperatures and that was maximum temperatures, okay, if I change it to, I would not change anything here, but obviously I have to change it there. So that will become now that, and this will become x. Okay, so remember that. Now these variables will be then x, and x. Okay, but let's go back to its relationship. Remember, so it's the constant and the dependent variable, the time and the dependent variable, and then maximum temperatures being the independent variable, and minimum temperatures being the dependent variable. Let's just go back and change that. So you can swap between these variables fairly straightforward, but remember, if you do it at one place, make sure that you change it throughout the script. Okay, so I hope you understand what I'm doing here. Okay, so remember we've got now, this is our independent variable. So we adding these independent variables. Remember, this is the coefficients, né? these are coefficients. So these are the coefficients that we generate. Okay, so we're generating these coefficients, so we add, and these coefficients then become our bands. Okay, and we're adding it, and this is just this, the values that we specify in terms of our visualization parameters. And again, play around with these numbers because if you change it, the maps will change quite significantly. So what is right or wrong, that's up to you. Play around with it, see what makes sense to you. And then we're just printing the coefficients. Okay, then we're just printing the coefficients. Remember, I'm printing here the coefficients for my region of interest as a whole. Let's do it here as well. I'm printing my coefficients for my region of interest as a whole. Okay. Or if you have a specific point, a location, you can put the geometry, that location in there, or I can use the inspector. So let's run it again. Oh, goodness, now I have to log in. Again, we had load shedding. So let me quickly just pause the video and log in, and then I'll be with you 5 seconds. Just hold on. I'll be back now. Okay, sorry about that. We're back. As I said, this beauty of load shedding, everything stops, and then everything have to be restarted. Okay, so here we're printing. You see, there's the prints, and remember, these are now the coefficients. Remember, this is the coefficients. Remember, so we're generating the coefficients. We're generating 3 coefficients. Which coefficient? The constant, the time, and the maximum temperature coefficients. And those are the coefficients, how they relate to our dependent variable, which is minimum temperatures in this specific case. And we basically just generate the equations of the coefficients for my region of interest. But you can do that if you use an inspector, you can generate those coefficients for any location. If you have a look there, there's the location, the coefficients. You see there's constant, time, and max. Okay, so these are coefficients. You see there as well, if I open up, these are coefficients, and you can see the difference between the normal regression and the robust regression. Okay, not much of a difference, but in general you go with the robust ones because they are serially uncorrelated, etc., etc. So anyway, that's OLS stuff. Okay, so let's quickly have a look and see what have we done now. Okay, so to make sense of this, I'm going to go back to Excel. Okay, to make sense of this, I'm going to go back to Excel because I've actually done this whole thing in Excel. Okay, so remember what we have now. We have in Excel, we have our dates. Remember, this is now January 1960. Let me make it a bit bigger. So this is January 1960. Okay, remember, if I go through this and I go to Format Cells and I go into date, you'll see it will be January 1960. Okay, so that's my date, 1960, January, 1960, February, etc. So that's a unique number. So that's what we've generated. I go back here. That's what we've generated here. Okay, that's what we've generated there. We've generated that time series, date. Remember, I've divided it by 8 zeros, and I'll tell you now why I've done that. Okay, so remember that. So there is that date series. Then remember, we don't calculate the constant per se. OLS will generate the constant. Okay, and then so we don't have a constant per se. OLS will generate the constant. Then we have our maximum temperatures. Okay, so that's basically what we've generated. Okay, so the OLS will generate the constant. So now we've got the constant, which will be generated. We've got our time series, our dates. Okay, we've got our TMMX and we've got our TMMM. So basically this equation is basically this part here, missing the constant. But remember, the constant is one value. So that's basically what we have here. So what we're going to do is we're going to make this one here. So this becomes our independent variable or dependent variable. So let me make it this color. So that's our dependent variable. And these two together with constant, let's insert a thing there and say make it constant, constant. So that is my equation. So what we specified here, that is what we specify here. So that's what we've done there. Okay, from 1960 to 2001. Remember, it's a scaled variables, etc. So this whole thing here, this what we've done here is basically this. This is what we've done now. Okay. And now what we're going to do is we're going to generate an equation, two equations. Now in Excel, we can generate this one. We cannot do this one in Excel. So we'll have to do this one in R. But as point of reference, let's use this one. Okay. So basically, and I've done that. So I'm just going to go into my data, and I go into my data analysis. I go to regression. Okay. You'll see my regression. There's my input range, my Y. What is my Y? My Y is E, which is, sorry, that should be F now, because I've just, okay, yeah, so that must be F. I've done it before. I've included the constant column. So that must be F, and then D and E is my two independent variables. Remember, it will automatically, and then we generate a constant. So that's my dependent variable, TMMM, which is F. My two independent variables, which is D and E, and it will generate a constant. I've got an output range. I'm not going to run it because I've already run it. And there sits the equation. Okay, now let's have a look at the coefficients. And there they sit. Intercept, minus 6.219. Let's go and have a look and see. What's my intercept? Minus 6.506. Okay, so very, very similar. Okay, minus 6.506. If we go into Excel, have a look, minus 6.219. So almost identical. One could expect a couple of, small differences simply because of, it's two different platforms that we work with. Anyway, so there sits our constant, which is generated. Let's look at this coefficient, 0,0000012. Now, what coefficient is that? Okay, let's have a look in Google Earth. See, that's a 0,0000016. Okay, let's have a go back. 0,00012. Okay, that's the value that we've generated there. Now, what value is that? Remember, it's 1, 2, 3, 4 zeros. Let's have a look and see. 1, 2, 3, 4 zeros and 1, 6. So that is time. See, that's my time variable. And obviously, this is then the coefficient of maximum temperatures. 0.72. If I go here, 0.71. You can see there. So these coefficients that we generated here using date, this, and this are virtually identical to the coefficients that I've generated here, that I've generated there. Okay, so that now, because we've got time, you see there we've got time 4 zeros. Okay, so now let's figure out why I'm using this value there. Okay, so remember, if I put this in an equation, it must be equal to the minimum temperatures. Okay, so let's have a look and see what I've done. Remember what I've said now. If I put this in an equation, I must get to a value equal to, or roughly equal to, minimum temperatures. What is minimum temperatures? Minimum temperatures is 15s, 16s, high teens, middle teens. That's my minimum temperatures. Okay, so let's have a look. So I copy this value here, that value there. Okay, 4 zeros, 1, 6. And I paste it there. See, 4 zeros, 1, 6. Then I paste the constant value, minus 6.5. Let's have a look and see, minus 6.5. Minus 6.5. So I copy that. And then I copy this variable. So I copy all three of these values, the coefficients, and I paste it into Excel. And then I take, obviously, remember, that must be multiplied now with the date. Remember, this coefficient here, this one here, that I've generated there, remember, it must be multiplied by time, because remember, it's time times this coefficient. Okay, so if I multiply, remember that's time for January 1960. So if I multiply that by that number, I'm getting this number. See, I'm getting that number there. Now, if I take this number and I add the coefficient and I multiplied my maximum temperatures with a 0.7, I get to 15. So that says to me that I must now Remember, this is 1, 2, 3, 4, 5 variable numbers. So I cannot work with this per se. I have to work with a number, a coefficient, multiply that gives me a value there. So if I didn't, okay, so let's quickly say, if I do this now, let's say I take it, let's make it 10. And I run it. Let's have a look and see what happens now. That's how you figure what this value will be. Okay, you see there's the value now. So if I copy that coefficient, remember the other coefficients are exactly the same. Remember this is now only have 2 zeros, not 4 zeros. And if I paste that value in Excel, in there, remember, see there's 4 zeros. If I paste that now into Excel, and it's only 2 zeros. You see the value that I get, 51 degrees, which is not close to my minimum temperatures. And that's how I know how many zeros I must add here, because my result there must be roughly in this number. So that's how I know that actually I cannot use 10 zeros. I must use 8 zeros, because I'm looking for that number there that's going to be in my equation there. That's going to give me a minimum temperature that's roughly equal to that. I hope that makes sense. Okay, so that's playing around with this number. I initially started, with, okay, so let's you see in the, let's use that value 18 zeros. So if I do that, now let's have a look and see what happens now. Okay, so if I were to, you see that's now that. So if I take that number and I copy it into Excel there, okay, and I run the equation, you'll see then I get a temperature of, minimum temperature of that, and that is totally impossible. It's not going to work, never. So that's how I know that I cannot use 18 zeros, I must use 8 zeros. Oops. And so it's trial and error, and that's why I love working in Excel. Okay, so that's how I figured out what that number might be. Okay, so that number must give me a time variable, because remember this is time, né? So that variable must give me a time variable that if I take that coefficient and I multiply it by time, I get to a minimum temperature value that actually makes sense. So let's just go there, back. Okay, see 15 degrees, which is basically 15 degrees there. You can see there, 15 degrees there. Okay, so that's how I've calculated or determined that value there. So I work with this equation and I duplicate it in Excel, and therefore I can know whether I'm okay with this equation or not. Okay, so that's the beauty of it. And obviously then we basically display it in our image. So if I go to my maps, there's my image, and this basically just gives me the ability to generate those coefficients for any location. So if I click there, you'll see it will give me the coefficients for that specific locations. Hang on, it's on its way, almost there. It's -6.8. There's the time variable, and there's the maximum temperature coefficient. If I go here, you'll see it will give me. So that's what's now being displayed on this map, is all the coefficients. You'll see there's the coefficients for that specific location. Okay, so that's the beauty of it. I can now model any location based on this regression equation, which includes a constant, a time, and maximum temperatures. Okay, and as I said, the beauty of this whole thing is I can run it in Excel. And you see, as I said in my previous video talks, if I run it in Excel, I understand automatically what I'm doing and what these things mean, etc., etc. And that helps me to relate to the code itself and to understand the coding and what I'm doing with the coding, because I can duplicate it with Excel. So there's ins and outs that you have to understand. But again, play around with the code, change the colors, change the variables, see what happens, but keep the basic of the code structure in place. Perfect. Thank you. Yeah, nice one. Appreciate it. Thanks for keeping me company. I appreciate you, and look forward to our travels together, our journey together. Stay tuned. Lots more to come. And please remember to like, subscribe. Yeah, please subscribe. We need to get to the magic numbers. So please subscribe, share it, and please send me a comment. Happy to engage with you, and stay tuned. I'll see you on the other side.